Hi everyone, my name's Brendan Zurweller. I'm an assistant extension and research professor at Mississippi State University. And today my poster presentation is entitled Peanut Cultivar Response to Residual Soil Test Potassium Amounts in North Mississippi. And so for the sake of time, I'm just going to jump right into the objectives of this research. And they're really twofold. So the first was to determine soil test potassium critical levels for peanut, and particularly on soil textures that are higher in CEC. So the study was conducted on two different soil types. One was a Marietta loam with an average CEC of around 15, and one was a silty clay loam with an average CEC of 37. And this was a calcareous soil, which is partly why there's such a high CEC. And on both of these soil types, we had 4 different soil test potassium treatments, or different residual soil potassium amounts. And so they range from K0 to K3, and you can see those amounts for both years in 2019 and 2020 in table 1 there. So as we go from K0 to K3, the soil test potassium amounts positively increase in both years. And we also planted 5 different cultivars among these 4 different soil test potassium amounts on both soil types. And these cultivars were Georgia-06G, Georgia-18RU, Georgia-16HO, Auburn NPL-17, and FloRun331. And so the first thing I'll run through on the results is the differences in precipitation timing that we observed in both years. And that was in 2019, really all the way to late season, there was more precipitation that was received for a total of 571 millimeters. And 2020 was drier with 431 millimeters, but I would say the difference between years that probably had the most impact on this research was in 2020 there was a lot less precipitation received in that early to mid-season time frame in development, when the plants are putting on a lot more canopy development and leaf area. And so in both years we did see a main effect of soil test potassium on pod yield, and particularly the effect was we saw a pod yield increase when we went from K0 to the K1 soil test potassium, whereas any soil test potassium amounts beyond the K1, so from K1 to 2 to 3, we did not see any additional pod yield increase. And this response was the same across all peanut cultivars, meaning that there does not seem to be different potassium requirements for the different cultivars that have slightly different canopy architecture and put on a different amount of leaf area. There was a interaction between soil test potassium and the soil types among the years, and this probably goes back to the timing of precipitation, where we suspect that in the higher CEC soils, the leaper, potassium is going to be less available because of the potassium adsorption to the soil exchange site. So and more available on the Marietta. So in 2019, where we had a good amount of precipitation early to mid-season, when the canopies are rapidly developing, potassium was not as limiting on that lower CEC soil. So we didn't see this, we saw a lower strength of the pod yield response to soil test potassium on the Marietta than we did on the leaper, the higher CEC soil. We saw a greater strength of that relationship, where in 2020, where it was drier early to mid-season, we saw a pretty similar strength of the relationship between pod yield and soil test potassium. So just to wrap up, some of the main conclusion of this research, and I think, what are the next steps of this research are these critical soil test potassium amounts that we observed, where we saw pod yield increase from the K0 to K1, are a lot higher than current soil test potassium amounts, where we would recommend a potash application on low CEC soils that are, say, sandy and sandy loam soil texture. So I think it would be good to follow up on this research and look at different soil test potassium amounts with modern cultivars in the more moderate CEC range, so that's 6 to 12. And then also verify on these higher CEC soils where if we have a soil test potassium amount, say at that K0 level, verify that we would see a yield response if we made a fertilizer application at the lower K0 soil test potassium range. And with that, I would like to thank you for watching this poster presentation. Thank you.